right, everyone. So today we are tackling some basic trig ratio problems, setting some groundwork for the problems you will encounter in trigonometry in the ACT. First question. In the right triangle shown, the legs are 6 and 8, and the hypotenuse is 10. We want to know what is sine of theta, being theta here is almost always an angle. So what is sine of the angle theta? And here's the one rule you just kind of have to know cold going into this. It runs through this whole topic. It's very common on the ACT, and that is SohCahToa. SohCahToa. What does this mean? It means these are the trigonometric proportions that you have to know. So sine is the opposite over the hypotenuse, SOH, sine over hypotenuse. Cosine is adjacent over hypotenuse, CAH. And tangent is opposite over adjacent, TOA. SohCahToa. Now, in this particular problem, to return to that, the side opposite angle theta is 6, and the hypotenuse is 10. So the sine of theta is 6 over 10, and once you reduce it, that becomes 3 over 5, and that's answer A. Question number 2. We are told that the tangent of angle theta this time is 5 over 12. What then is the sine of theta? So let's just draw the triangle if we haven't already. And just remember, for a standardized test, you do not have to make your triangle diagram exact. Just make it roughly the right proportions, and that will be good enough for whatever you have to do, okay? So then now that we have our triangle, let's remind ourselves that tangent is opposite over adjacent. Okay, so the opposite side is 5, and the adjacent side is 12. Now we have to find the third side, and we're going to have to use the Pythagorean theorem. So 5 squared plus 12 squared equals the hypotenuse squared, right? That comes out to 169. So divide 100, or rather take the square root of 169, and the square root then comes out to 13, giving us our hypotenuse of 13. Now remember, sine, SohCahToa, sine is opposite over hypotenuse. So that's our proportion, 5 over 13. And that's answer C. And of course, the obvious distractor here is the 5 over 12, which looks like the numbers they've given you. And indeed, they are the numbers they gave you at the outset. And it's pretty close to the actual final proportion that we were looking for. But remember, that's the tangent you were given. It's not the sine. You have to make the distinction. And so while the numbers are close, they actually have very little to do with the right answer, even though they look similar on paper. Question 3, one more kind of triangle this time. We have a right triangle that has a hypotenuse of 20, and we have one acute angle that measures 35 degrees. Which expression gives the length of the side opposite that angle? So first, let's just remind ourselves a little terminology. An acute angle is one that is less than 90 degrees, which is actually redundant information here since they already told you this angle was 35 degrees, but it's just good to do a little refresher. So nothing new, no particular tricks or anything. We're dealing with a 35-degree angle, and we know that. So to return to the problem, pick the ratio that fits the two sides. Okay, so we have the hypotenuse, and we want the opposite side. So what kind of relationship are we dealing with here? This is opposite and a hypotenuse, therefore we want the sine, right? Sine is opposite over hypotenuse. That's the relationship we're looking for. So now we can set up an equation. Sine of 35 degrees equals x over 20. X is what we're looking for, obviously. And so multiply both sides by 20. X equals 20 sine of 35 degrees, or 20 times sine of 35 degrees. And that is answer B. Okay, one last one for this set. From a point that is 50 feet from the base of a tree, the angle of elevation to the top of the tree is 40 degrees. Which expression gives the height of the tree? Okay, so these kinds of angle of elevation problems are almost always dealing with tangent. And it's important to remember that this is a triangle problem still, even though it's not there. So if you just draw the tree and you draw out the distance from the base of the tree to the point of observation, and then you look up to the top of the tree, you have a hypotenuse, right? So this is still a triangle problem. This is a trigonometric problem, even though it's not obviously presented to you as dealing with triangles. So, as I said, this kind of problem is dealing with tangents. So tangent of 40 equals the height of the tree, or we'll call that x here, x over 50. I'll say that one more time. Tangent of 40 equals x over 50. Multiply both sides by 50 in the algebra, and the height is 50 times the tangent of 40, and that's answer D. So basically, if you know the three SohCahToa ratios, and you can sketch the triangle, you just pick the ratio that fits the relationship. And these relationships really are the cornerstone for ACT trig problems. If you learn them, you'll be doing yourself a big favor on the exam.